I'm starting with the finished product of a cord replacement to a random orbit sander. Same idea can go with any other power tool. What I encountered when I opened this up was special connectors that I couldn't find replacements of, so I had to splice the wires. So you'll see that in the video. You'll see that the other lesson I learned from this particular project is just get the exact same cord that came with the power tool to begin with. I thought I could just use a heavier gauge cord, but that meant the cord wouldn't fit through here, and it would have made it more difficult to ultimately splice, which is what my issue that I had to solve for. But going with the exact same cord size and number of conductors was also an important tip. So the other thing is make sure you keep track of all the hardware and keep track of things that might accidentally get dislodged or moved out of place as you're replacing the cords. Take pictures or movies of disassembly. That's the beautiful thing with phones these days, because I had to go back to the video to see how the cords were routed, the wires were routed, and how or what went where. So if this is your first time, it's certainly worth using a phone to record some of the process. So enjoy this video on replacing a power cord. Hello, Fix-It Tony here. Today I have a repair project. When I had a puppy, we still have the dog, she decided to get really chewy, and I had left my Orbit palm sander out on my screen porch after working on refinishing our cedar fence, and she got into the box and chewed off the tip, the cord, and right through it. So I really like this orbit sander. It's a Porter cable random orbit sander, so it rotates but also does a random sort of back and forth. So as part of fixing this, I have to get this cord out here, and to do that I have to begin to take this apart. And as you can see here, there's two halves, and it looks like in order to separate this I have to remove this shield or the shroud at the base, and there's two screws, one there and one there. And to remove this half clamshell I have three screws, 1, 2, and 3, and that should do it. There might be a screw hidden around this shroud. So I did inspect this before starting this video. I did inspect the screws, and it's a Torx screw. So I have my handy dandy Torx screw set here, and it's one of these. And I'm going to start by removing the base here. I do have a replacement cord that I bought on Amazon. I wanted to get one with the ground and a 9-foot length. I wanted 9 feet because if I was sanding a sheet of plywood, what you don't want is the cord to hang up on the edge of a sheet of plywood. So a sheet of plywood is normally 8 feet. Get an extra foot, and that'll help prevent some undue stress at some point in the future. And I couldn't separate these two halves because there was a rubber band. So I'm going to remove this rubber band belt, and then I should be able to just lift this up and out. There's a rubber gasket here. I didn't want to separate it out and unrip it, so it was more of a open it and lift it out. Yep, there are 2 more Torx screws. Let me see here. 1 there and 1 there. So, yep. Definitely need to take that off. Okay, got all the screws out. And unfortunately, there's a sticker right here that provides the information, model number, serial number. A couple of days have gone by, and what ended up happening was I ended up trying to push a 3-wire, 3 conduit, 3 conductor, 14 gauge wire through this opening. The original factory cord was a 2-wire, 2 conductor, 18 gauge. So I just ended up getting from my favorite online retailer a 18 gauge 2 conductor to basically match what I had already on my Porter Cable random orbit sander. So this hopefully is going to go a lot easier. I want to match how this was inside here originally. So it was basically like this. Now it looks as though this wire, the neutral, is going to be long enough. But my black power wire has to go all the way to this switch, and it's got to get tucked down here, and then it's got to cross. See that there's a little groove right there? It's got to go in there, and then it's got to go around this screw, and then it's got to come down below beneath this wire, which is coming back from the switch. So this is power from the switch when the switch is on, and this has a little push type connector, and what it was going into was the variable speed switch. So then it's got to go under and then up and then plug in. So remember what I was talking about earlier too is I saved the original connector. So my thought was if I should splice this wire right here and splice it in a way that I can then tuck it in that space down right in there. So I could do that. The other option is that I also ordered online a new flag style connector that I'm going to try to go brand new and go all the way through without splicing it. My preference would be not to splice. Okay, that's about an inch and a half, or a little bit more. You only want to do this operation once. I'm not pushing down hard to cut through there. A very tiny set of side cutters. And what I can do is just nibble around the edges. Holding back. You can see I'm just trimming it carefully. Not being aggressive. You know, less is more many times. Now I'm not going to use a sharp implement, but you know, I have my Torx screwdriver here, And I should be able to just, there we go, push that all the way down until it seats. Then I can bring this around, bring the wire around, push it down. Did this O-ring actually fit right on there? You know, I think it may have. And it helped to keep this stable and vibration free. So I need to pull this connector out so I could better route these wires. But as you can see here, I think there's a little button right there that I need to push in and to pull this out, because this is really, you can sort of, yeah, it's sort of catching. Let's grab it from the needle nose. There. Got the little bugger. All right. So I got it out. All that wrangling caused this O-ring to get dislodged. So it seems like for every, it's one of Newton's laws, for every action there's an equal and opposite reaction. So let's take a look-see here. Well, time has gone by, and I am taking electrical tape and taping this little motor down, because it is loose and it will wobble. So, and this brush, it's got some wear on it, but it's still in good shape. Now I'm afraid this is going to pop up. So what am I going to do? I could try to put more tape. I have received my flag connector. I ended up finding one that was insulated. It's the only kind that I was able to find. And the plastic covering is very rigid and also very tall. So if I were to model this, putting it in here, I'm afraid this is way too tall, taller than the original factory. So let me find that original factory one. So here's what the one in the factory came from, and you can see how much taller this one that I got, and it's going to interfere with, I think, reassembly. So I'm going to abandon this particular flag connector. So now part of the process is finding my splice connector. I'm using 18 gauge, so I could use the red connector. I'm using 2 of these red connectors from my splicing kit. This particular splicing connector system has a ring of solder that I'm going to heat, and it'll melt and it'll fuse the connectors together. The other issue I need to take into account is I need the splice to fit in between the 2 little channels here and here. So I'm going to need to trim on each side of this soldering kit, essentially on the inside of this red banding, which this. trickiest part when you're inserting this is that all the strands go in. So what I'm doing is inserting the wires, and because I loosened them, the wires are going past each other, if you can envision that. And you can see that the heat shrink tubing is also covering part of the insulation, and that the real business end of the connection is going to be this soldering joint right here. And you can see that there's just a little bit of copper wire showing on either side, because as this solder melts, it's going to ooze and fuse this entire segment of wire. So in order to melt the solder, I have an electric heat gun. It's one of these smaller handheld versions, and you'll see that it has a heat shield that's curved, so as the heat shoots out of here, the heat shield helps to keep all the heat sort of evenly. So I'm going to try to do the best I can. I think that's good. Now this tip is very hot, so I have to really be careful when you're setting this down that you're keeping your fingers and other flammable objects away from the tip. Have a sip of coffee. Now this is still very hot. I'm not going to touch it yet. I'm not going to manipulate it yet. Brush goes in this hole, this little cavity right here. I'm going to have to fold this down, and then it's going to come down and across, and it's got to fit right into here. So I'm going to trim this back maybe 1/8 of an inch, and then I need to strip only about 1/4 inch off. Now on the return wire back to the power cord, I'm going to tuck this back in here deeply, and I have to cut quite a bit off because this wire that I'm splicing, it all has to fit into this little area. Like the other one, I'm going to need to trim the length about the same location. I want to have some heat shrink tubing against the wire, so that's always something I want to do. I'm not going to push the brush in first. I'm going to make the connection first, and then I'll seat everything where it needs to go. Now I can apply heat. I like that. It's got to drop in sort of perfectly even. I have to be delicate not to dislodge the brushes from their housings. Remove some of the tape. When I look at the other half of the housing, the shell, yeah, good, it's coming through on the camera, you'll see that I need to replace or put back these little rubber pads. They go on every point where there's sort of this cross member. And fortunately, I know which way they go because the indent helps me track it down. There's 1, 2, 3 points of contact, plus one that goes on top of the motor. When I blew this out with compressed air, I did remove these bumpers. This little orange piece is removable. I didn't know it at the time, so I blew it out with the air and it flew away. Fortunately, I was able to find it and track it down. But this also helps with vibration. And now it's just a matter of closing it up. Before I do that, I do need to remove the electrical tape. This white trim has to fit somewhere in that little narrow pocket. And then the motor just popped out. I can see how this could be tricky to reclose. That's looking good. This side's looking good. So what I should be able to do now is put my screws in. I'm going to start on this side. There. Reassembled. I'm tempted to plug this in to see if this thing even spins without any of this pad on. Shall we try? Let's. That's good. That's the high speed. Yes, it does work. There it is. We have completed the replacement of the cord, power cord for a random orbit sander. This was definitely a challenge and did take time.